Hey everyone, your homework today is to complete the, what's this called? Word problems to equations Desmos that you should have got started on in class today and then maybe worked on a little bit after you finished today's quiz. Um, so I'm going to assume that, I don't know, you probably got through the first 4 questions in class, either with your teacher or on your own. So I'll complete questions 5 through 10 in case you get stuck on any of those. So I've already got question 5 loaded up here on the screen. And it says 155 seventh graders are going on a field trip to SF, which I believe is San Francisco. There are 7 buses full of students. I think that's supposed to say full. There are 7 buses full of students, and 22 students are being driven by their parents. How many students are there in each bus? Okay, so let's hear. Let me kind of get all the information we got here. Okay, so this is important, right? There's 155 students total, it looks like. So I'm gonna just kind of mark this. Okay, that's my total. And then here's another piece of important information right here. 7 buses full of students. And I notice that they don't give me a number of students there, right? They just say full of students. It's like a mystery. And that's usually a good clue that that's something we're gonna need to represent with a variable. And then the last important piece of information I see is 22 students are being driven by their parents. And so those students, my line got a little weird there. Those students obviously aren't on the buses, right? So the last part says how many students are there in each bus? So that's the thing we're trying to figure out, right? This is what the question is. Well, we want to set up our equation so that when we figure out what our variable equals, it answers the question for us at the same time, right? So they didn't tell us how many students are on the bus. The question literally is how many students are on each bus. Let's make our variable s represent how many students are on each bus. That seems to make a lot of sense to me. So s will be the number, don't just say students on the bus, because students are a physical object. They're a thing. They're a living person, right? You can't represent something like that with a variable. Variable should represent numerical quantities. So we say the number of students on, and don't say on the buses, because that would mean your variable stands for all students combined on all 7 buses. We got to be more specific than that. Number of students on each bus, right? That's what we're trying to figure out in the end. All right, so next it says write an equation using this variable to represent the situation. So when you've done questions similar to this in 6th grade, 5th grade, whatever, the natural tendency and what you've probably been trained to do is to immediately start solving this question. You can look at this question and go, okay, there's 155 total and 22 are in cars, so they're not on the buses, so I'm gonna do 155 minus 22, and then that's gonna get me some number, and if I divide that by 7, I'll have all the students on the bus. And you get the right answer. That's great. The point of this unit that we're in now in 7th grade is learning how to shift our perspective from immediately trying to solve a question using an arithmetic or arithmetic-based strategy, such as the one I just described, and now solving it using an algebraic strategy, which requires us to shift from immediately trying to solve to instead representing what we know first, then solving from there. And the solution steps, solving the algebraic equation, require the exact same arithmetic that I just said in the strategy a moment ago that probably made sense to you, right? The strategy that you would probably be used to doing a question like this would be 155 minus 22 equals, what is that, 123. No, it is 133. I was right the first time, 133. And then you're going to take that 133 and divide by 7. And what's that going to be? A little less than 20? 19, yeah, because 20 would give me 140, right? And take 7 off of that. So it's got to be 19. So the answer to this is 19. This is how most people would do this. We're looking for you to shift from immediately jumping into that into first representing what you know from the question using a variable, And then you're going to use essentially those same steps I just listed out to solve that equation. So let's see here. We know that there's 155 students total. And then there's these 7 buses with a certain number of students that we're representing with as S. So I know that there's 7 times S students in this situation. Okay. And then if I add all the number of students on the buses, which is my 7S, to the students that are in the cars, right? Then that's supposed to equal the 155 students total, right? So in my strategy up here, I immediately started thinking about subtracting things off, dividing things, right? To get to an answer, to break things down to an answer. But when I'm representing things as an equation, in this case, I'm totaling things up. I'm saying, okay, I know there's these 7 buses. I know each one has S students on them because I don't know how many that is. I know there's also these 22 that are in the cars. And I know that if I put all those things together, it equals 155. So I'm totaling things up to make a representation. And now I'm going to use the operations that I have up here in my strategy to break that representation down and get the same answer I already got, 19. It's just a different way of doing it and a different way of thinking about things. All right, so let's see here. We're supposed to show our work. I'll do that. I'll show my work using the Desmos tool here. So I would start by writing that equation I just wrote out. 7S plus 22 equals 155. You can use the drawing tool like I'm using right now, or hit this text tool right here and type. And also, if you want to make your teacher's life easier, when you use the text tool, you can come over here and you can change colors if you like. And you can also make the font bigger, which sometimes makes it easier for teachers to see in the different views that they have. All right, and so to solve this equation, I'm going to do the same steps I did over here in my original solution strategy. I need to subtract that 22. We've been working on this in class for a while, whether you're in my class or Mr. Wong's class. So hopefully you're getting pretty good at this. I'm not going to explain the solving of the equations too much. I'm going to focus on talking about how to make the equations from the word problems, because that's kind of what this assignment's about. You're kind of already supposed to be getting pretty good at this solving part, this part here. So we're left with 7S equals 133. Same thing we got up there in the top left. And then I want to divide both sides of this equation by 7. And I get S equals 19. Now, I always say, and I would imagine Mr. Wong probably says the same thing too, if you get asked a question in words, you should answer it in words or write some sort of conclusion. They don't have to be paragraphs. They don't have to be novels. It could be something as short and simple as, let's see here, I'm gonna get my text tool. There, hey, there, no, that's not what I want. There were 19 students on each bus. Simple as that. All right, I think I would say that one's done. Let's move on to number 6. You are going to CVS to get some snacks. You have $17 to spend. Let me underline some of this stuff as I go, some of this important info. All right, so $17 to spend. That sounds like it's probably gonna be a total to me. I bet I'm gonna buy some things, and if I add up all the things that I bought, it's gonna equal 17. That's usually how a question like this, that starts like this goes. I haven't even read this question. I didn't write this, Mr. Wong did, so let's see if I'm right. You have $17 to spend. You buy a drink for $3, okay, that's, like I'm almost thinking of like building a receipt in my head right now, things that are gonna add up to 17. Then you buy a few bags of chips. I noticed they didn't tell me the number of bags of chips. So I'm already thinking that's probably where my variable is going to come in. If each bag costs $2, how many bags of chips can you get with your $17? Or how many bags of chips, like let's say you spent the whole 17, how many bags of chips did you buy? All right, so I think the fact that they said buy a few bags of chips here, but didn't say how many, and then the question is, how many bags of chips can you get with your $17? I think those two things combined make it pretty clear that our variable B has to stand for Don't say bags of chips, right? A variable can't stand for a physical object. It needs to be number of bags of chips we can buy, or we bought, or we're gonna buy, something like that. We can buy. We'll go with it like that. All right, so now, rather than immediately trying to start solving by doing 17 to minus 3 and then divided by 2, we're gonna represent what we know, almost like build a receipt here. So we know that there's this $3 drink, right? So let's put that in there right away. And then there's some number of bags of chips, which we don't know what that number is, but we know it's B, right? We know we can represent it in our equation using a B. Okay, and each one costs $2. Each bag of chips costs $2. So if we took the $3 and we added $2 for every bag of chips for however many bags we're buying, so 2 times B, right? 2 times the number of bags of chips, it's got to equal a total of $17. So there's our equation there. Let's write it out on our workspace here. Usually you're supposed to write a term with a variable in it before a constant term. So I'm just going to make a little switch here. I'm going to write 2b plus 3 equals 17. You don't have to do that. It doesn't change anything. It doesn't change the work we're going to do. This is just the way you're supposed to write it. All right, so I look at the operations happening to my variable. I see it's being added to 3. I see it's being multiplied by 2. So I'm going to want to subtract 3 and then divide by 2. So let me subtract 3 from both sides of my equation. I get 2b equals 14. And now I want to divide both sides by 2. Use a fraction bar to represent division. And we get b equals 7. That's our solution. And so remember, b stood for the number of bags of chips we could buy. And so we write a little conclusion that just says that, right? I'm going to put a little text box here. We can afford to buy 7 bags of chips. Boom, done. All right, let's move on. Micah is renting, hold on, give me a second. Micah is renting a bike for an adventure. It cost $11 to rent. Okay, let me underline that. That's important info. $11 to rent, and then plus $8 for every hour. I love when math questions say plus in them because it makes it super easy for me to know that when I write my representation or my equation, it's going to have a plus symbol in it. Plus 8 for every hour. If Micah paid $51, how many hours did he rent the bike for? So we were never told how many hours Micah rents the bike for in the problem. And then the problem literally ends by asking us how many hours did he rent the bike for? So those two things combined tell us that we don't know that information, but we're going to want it. So let's represent it with a variable in our equation here. So this one has lines there that I don't want. All right, so H is going to be not just hours, right? Hours are a concept of time or whatever. Variables only represent numerical quantities. So we're going to say number of hours. Micah rented the bike for? Yeah, Micah rented a bike for. If I was your English teacher, I would nitpick and say, you can't end a sentence with the word for like that. We should say the number of hours for which Micah rented the bike, but I'm not an English teacher, so I don't care. All right, so now we write our equation that's going to represent this situation. We're going to use our H in it. We know we're going to have a plus in it, right? Because the word problem said $11 to rent. So let's start there. I'm going to make the same mistake I made on the last one by starting with my constant term. Maybe I'll just leave it this time. So 11 plus $8 for every hour. Okay, so if you want to find a total, if you know something costs $8 for every hour, And then if we knew how many hours, we would multiply, right? We would do 8 times however many hours, but we don't. So we just do 8 times h. And then that's supposed to equal the total of $51. So yeah, this time I will just write it this way. Let's see here, 11 plus 8h equals 51. And so I see that my variable is being multiplied by 8 and added to 11. So I'm going to work in reverse GEMDOS order of that. I need to worry about the 11 first, then the 8. I'm going to subtract and I'm going to divide. So the fact that the 11 is over here now doesn't change anything. I'm still just going to subtract it from both sides of the equation. And I get 8h equals 40, right? 51 minus 11 is 40. I'm going to divide both sides by 8. And I get h equals 5. So there's my solution. And what was h supposed to represent again? Let me go back up here and check. Number of hours Micah rented the bike for. So I can use my solution for h here to write a little conclusion. Micah rented the bike for 5 hours. Boom. All right, let's do another one. Chencho's baseball cards. Oh no, someone spilled water on Chencho's baseball cards and half of them got wet. He went to the store and bought 17 cards to replace his collection. Okay, I noticed they say his collection, but they don't say how many cards he ever had. Well, the next sentence says, now he has 33 cards. Okay, so that's now though, right? Like that's after he bought this 17. So let's look at the important stuff here. Half of them got wet. Then he bought 17, and now he has a total of 33. How many cards did Chencho have at first? So that's our unknown thing, right? They never said how many cards he had to start with at the beginning of this whole thing, and that's what the question wants to know at the end. How many cards did he start with? So that's a piece of information we don't have that we're going to want. So let's use it as our variable. So we're not going to write C represents his cards or the cards that he had, right? Because cards are a physical object. So those don't go in math equations. Numerical quantities do. So the number of cards Chencho, I guess we can say like started with. You could say number of cards in Chencho's original collection, something like that. Okay, so let's think about it. C is the number of cards he started with, right? We don't know how many that is, but we do know that in this process of getting from how many he started with, which is C, he went from there to 33, because the question ends by essentially saying now he has 33. So there's this process that he went through going from C to 33, and that's what we're going to represent is our equation. Well, I know the first thing that happened to Chencho's cards is half of them got wet, right? And so if half of them are gone, we represent that by dividing by 2, right? Or multiplying by 1/2. Either of those work. I like to do it like this, C over 2, like that, right? So that says C divided by 2 or 1/2 of C. There's multiple ways to read that, but that's essentially going to be how many cards he had after half of them got wet. But then he went to the store and bought 17, right? So we add 17 to that. And now he should have the 33 that the question says. So cards he started with divided by 2, but then add 17 equals the 33 that he has. All right, so let's solve this one. I'm going to start by writing it in my workspace here. C over 2 plus 17 equals 33. So I see my variables being divided by 2. That means I'm going to need to multiply by 2 to solve. And I see 17 is being added to it. So I'm going to start by subtracting 17 from both sides. And I get C divided by 2 equals 16. Yeah. And so now, because the number I want, when it's divided by 2, I get 16. let me multiply both sides by 2 to see what the number I actually want is. I like to write, when I'm going to divide or multiply both sides of an equation by 2, I like to put that multiplication over here on the side up on parentheses. You could also write dot 2 underneath both sides if you like that better. And we get to C equals 32. So what does that mean? It means Chencho started with 32 cards, right? Chencho started with 32 cards. Boom. Done. Let's move on to the next one. Hey, look, it's about me. Mr. Thomas wanted to give some candy to his favorite class. Mr. Thomas doesn't have favorite classes. He had 70 pieces of candy to give. After he took 2 for himself, I don't even eat candy like that, but whatever. He split the rest among his 17 students. What class only has 17 students? Such a weird question. How many pieces of candy did each student get? All right, so I noticed that in the question, let's look at the important pieces of information here. I noticed that they're telling me I started with 70 pieces, right? I had 70 pieces to give. For some reason, it does not want to activate my drawing tool. There we go. Now I see that I took 2 for myself. So if you were thinking about just solving this question really quick, you'd probably thinking, okay, let me do 70 minus 2 right off the bat, right? We are going to subtract 2 when we go to solve this equation later. I just want to remind you to start instead thinking about how to represent this rather than how to solve it. Your first idea should be how to represent this, not to solve. All right, so he took 2 for himself, and then he split the rest among his 17 students. So we're probably going to wind up dividing by 17, right, to figure out how much each student got. So how many pieces of candy did each student get? I think that's going to be the thing we need to represent with a variable, right? We're trying to figure out how many pieces of candy each student got, and they never told us that in the question. So I'm going to let C be number of pieces of candy each student received. I probably just spelled received wrong. I don't know. I always get that one wrong. All right, now write an equation using the variable to represent the situation. All right, so we had 70 total to start with, right? I'm gonna start this one like that. I know that all this candy that I'm handing out, eating for myself or whatever, it should total up to that 70 I started with. All right, and I know that there's the 2 that I ate for myself. So let me put that in there. And then after that, I should be able to take that 2 and add it to all the candy that I gave the students and have that equals the 70 I started with. Well, there's 17 students and each one of them got C pieces of candy, right? So 17 times C should equal that missing piece of my equation. So I purposely wrote the equation on like different order, right? With the numerical part on the left side and the more like the side with the variable on the right, just so you can see that it's totally normal and okay to have your equation that way too if you want. So let's do it this way. We got 70 equals 2 plus 17C. So we're going to subtract off those 2 pieces of candy that I ate for myself, right? But we do it to both sides. We get the 68 pieces that are left. That has to equal the number of pieces every kid got times 17, since there's 17 of them. And now we divide both sides by 17 to figure out how much candy each kid got. 68 divided by 17, I believe, is 4. So it looks like C is going to equal 4, right? And we can write that as 4 equals C rather than C equals 4. Doesn't matter. And we're going to write a little conclusion. It says each student got 17 pieces of candy. Boom. All right, last one. Tavel? I'm not sure. Oh, a Tobble. No, that sounds wrong. Tavel. All right. Tavel wanted to get some pizza, so he spent 1/4 of his monthly allowance. Oh, okay, we got fractions and stuff going on here. All right. spent 1/4 of his monthly allowance. All right, I feel like we're going to have something divided by 4 or 1/4 times something in our equation here. He then gave $5 to a homeless person outside the pizza place. Okay. If Tavel spent and gave away $20 today, okay, so I think that's total, right? Like the pizza plus the, I guess, the gift. Yeah, we'll call it the gift to the person outside the pizza place. That's supposed to be a $20 total, is the way I read and understand this. What is his monthly allowance? Okay, well, I see here that he spent 1/4 of his monthly allowance. So, like the pizza is a spending, right? So this has got to be 1/4 of allowance. And then the gift, that was just 5. They tell us that in the word problem. And then those two things together are supposed to equal this $20 total. So my equation is essentially going to be this: 1/4 of his allowance plus $5 equals $20 total. I don't know how much his allowance is though. They didn't tell me that in the problem. And I noticed that the question that I'm trying to answer is what is his monthly allowance? So they didn't tell me in the question, and it's something I'm supposed to answer. And I know I'm going to need it to make my equation. So let me make the variable be, let's see here. Let's just say Tavel's monthly allowance. And you might be thinking, well, wait, Mr. T, an allowance is a thing. It should be a numerical quantity. And I'm like, this one's kind of borderline because an allowance is sort of understood to be a numerical quantity that you're receiving. So I think this one's okay. All right, so now let's literally just copy this equation that I wrote over here in the like maroon color, except where I wrote the word allowance, let's just use our A, our variable that stands for the same thing. So I could write 1/4 times A. This is an appropriate way to do this. You could write 1/4 times A, but more often than not, you see it like this instead. You see A over 4. Those two things mean the exact same thing. They're just different ways of writing them. And this way is like your variables being divided by 4. And in this way, it's more like, nope, that's different. Not the A down at the bottom. This way is more like saying you have a variable A and you have a coefficient of 1/4, right? Just like you would have, 3A, that's 3 times A. 3 is your coefficient. This is 1/4 A, 1/4 times A. 1/4 is your coefficient. But let's do it this way. Just because in 7th grade, this is the way you see it more often. But as you get older and into different forms of math, the fraction way is actually the way you'd write it more often, I think. All right, so A over 4 plus the $5 gift equals a total of $20. All right, let's write it out in our workspace and solve it. I see that my variable is being divided by 4, so I'm going to need to multiply by 4 to solve. And I see that it's being added to 5, so I'm going to need to subtract 5 to solve. And I'm going to start there. Minus 5 from both sides. I get A over 4 equals 15. I'm going to multiply both sides by 4. This time I'll use dot 4 on the bottom instead of parentheses on the side. And I get A equals 60. And so this solution tells me that, what's his name? Tavel. Tavel's allowance is $60 per week. Monthly allowance. Okay. I guess that's a reasonable monthly allowance. That'd be a lot for a weekly allowance. Tavel's monthly allowance is $60. All right. I think we did it. And that's it. Let me get on out of here.